The Context Biox 3005 is another one made in collaboration with Ulrike Kappler from the University of Queensland. It's another pretty straightforward one, but it has some really nice twists in it. So at a fundamental level, it's just the BCA assay for protein. That assay requires that you make a master mix, which consists of this reagent A, with some of reagent B. Now, interestingly, the amounts that you make are quite significant. So we actually use the 5 ml pipette, which is quite unusual in the context, but there we go. That's quite nice to be able to use that occasionally. And I'm just going to mix that with a couple of hundred microliters of this reagent B, and uh, the proportions are probably not 100% right, but they are good enough. I'll replace the lids, and I'm quite pleased with these animations for putting the blue capped tube lids on. Once we've got the lid on here, then we can select it and mix it. The mixing obviously is a very important part of the process. If we sample from that without mixing it, we'll get into some strife. So I'm going to create a plate with a whole bunch of wells. I won't use all of them, but I will set up a little standard curve using 5 to 15 microliters of the BSA. So I'll put 5 microliters in here, 10 microliters in the next well, and then 15 microliters in the one after that. So let's pick up these samples. And then I'm going to put 200 microliters of this master mix into the first 4 wells. Now, as soon as I do that, I'll start the reaction. But at this temperature, room temperature, the reaction won't be going too quickly. It is a reaction that we want to go to completion anyway, so not too worried about it accelerating. Now, that reaction is ticking over. We want to get the results a bit quicker. 2 strategies. One would be to increase the temperature, because the nice thing about this context is that we've put in a nice temperature dependence. The other, of course, is the simpler one, which is just to increase time. So if we just increase time, we can see the reaction developing, and after about half an hour or so, we'll be in a situation where we can read these absorbances. In fact, let's put something sensible in. I think 562 is about the wavelength that we want. And if we measure the absorbance, then yeah, but we get a nice sort of concentration dependence there. It's not brilliant, but it's not terrible. So that's all fine. Let's try this again. This time I'm going to put 200 microliters of the master mix in and into here, and I'll put another 200 into here. And this time I'm going to ramp up the temperature a bit. So let's stop the stopwatch and restart, and let's get 15 microliters, which we know gives a nice purple result, and pop that into there. So the reaction's started. This time let's bump the temperature up to 60 degrees. So nice high temperature. Actually the highest temperature that the system will take. So this plate is now warming up to 60 degrees. It's not going to be instantaneous. It's actually going to take a few seconds for it to get to 60 degrees, just like it would in real life. But what we'll see, and particularly if we just increase the time as well, just so we haven't got to wait too long, if I just put the time up modestly so it's just ticking over a bit, you can see that color developing a lot quicker now. So we've got a temperature dependence on this reaction, and that's going to give us the result in less than quarter of an hour. So if I take the time up, you can see, oh, it's really going quite quickly now. But can you see as well that with this plate at 60 degrees, we started to get a bit more color in these samples. And that's a really interesting thing. I've made it so that the master mix itself will start to degrade a little bit at higher temperatures. And in fact, it's continually degrading, and temperature will make it go much faster. So if we increase the time a lot, you see how everything just starts to become purple. Even the master mix that's sitting at 4 degrees C on the bench over 12, 14, 16 hours, look, is starting to become colorized. And this is really great because this really keeps the students on their toes. They can't just put the things in and whack the speed fully up to this enormous time dilation factor. They have to actually have some discipline, put some thought into when they're taking the readings, and they can't afford to just leave it to overcook. So it's just like real life. You wouldn't set up the plate and then come back 2 days later to read it. So really pleased with this one. We've got a couple of different threads going through. We've got the reaction between the protein and the constituents in the master mix producing the color, but we've also got this time dependent and concentration dependent production of the color overlaid as a background thing on top of that as well. So this is something that's really going to help the students with the discipline and taking readings at the right time, even for a reaction that goes to completion.